How's it going, everyone? We are talking about The Last of Us, the TV show in particular, and how a virus as depicted in the show could not actually happen in real life. Because a virus spread through biting just could not spread so fast, so far, that it creates this kind of global pandemic as depicted in the show. And the reason it can't spread like that has to do with the mathematics of how different viruses spread. So we're going to go through that, and we're actually going to compare that to some other fictional viruses which spread in somewhat of a more realistic manner. So let's go temporarily to the whiteboard. Let's say we have one person infected, call them patient 0, and let's say on average each infected person would infect 3 people per week. Well, we can make a chart for which week it is and how many people are infected. So week 0 we have 1 infected, then 1 week goes by, 3 people are infected. 2 weeks go by, each of those 3 infects 3 people, so you have 9 people infected. Week 3, you have 27 people infected, which is 9 times 3, right? Week 4, each of those 27 infects 3 people, so you have 81 people infected, and so on. You'll notice that each time we are multiplying by 3. So you could say that the number of infected, let's call it n, equals 3 to the power of t, where t is the number of weeks that have gone by. For each week that's gone by, you just multiply by 3 again. Now consider a situation where you have a different virus which has every infected person infects 10 people per week. Okay, so that's going to be 10 to the power of t. So if we have our week, number of weeks that have gone by, and the number of infected, okay, again, week 0, we just have our patient 0. Week 1, we have 10 people infected by that patient 0. Week 2, we have 100 people infected, 10 times 10. Week 3, we have 1,000 people infected, 100 times 10. Week 4, we have 10,000 people infected, 1,000 times 10, right? Because each week, every infected person that's been recently infected infects another 10 people. Now, look at the difference, okay? When we have the virus spreading such that each infected person infects 10 per week, we get 10,000 newly infected in week 4. But when each infected person infects 3 per week, we have 81 newly infected in week 4. Okay, well, 10,000 is a lot bigger than 81, even though only 4 weeks have gone by. And that has to do with this base of the exponential expression. Okay, so if we were to generalize that, we could say that the number of infected, depending on how many weeks or months or days or hours have gone by, is equal to the base of our exponential expression to the power of t, where again t is the number of days or weeks or months or hours, whatever unit of time we are working with. And the larger b is, that's our base, the more easily the infection spreads. The smaller b is, the slower the infection spreads, right? Like if b is 3 versus b is 10. Well, what b is depends on the nature of the virus, okay? So the fastest viruses to spread are the airborne ones, okay? Infected person exhales and everybody around them is going to inhale some of that air, okay? Now, what's interesting is that the Last of Us TV show is actually based on a video game. And in that video game, depicted in the background here, the virus is actually airborne. And so it makes sense that it could spread much more quickly and turn into this global pandemic, which they changed for the show, right? Making the spread actually not as realistic, right? Now, why did they change it? Now, in the video game, because it's airborne, you have the characters wearing masks a lot. Maybe they didn't want the actors wearing masks all the time in the show. Maybe that's why they changed it. Although Pedro Pascal wore a mask all the time in The Mandalorian, and that show was a huge hit, at least for the first two couple seasons. But in any case, it would have been more realistic had they kept the virus as airborne, but they decided to switch it to being spread through biting, which makes the situation much less realistic. Now let's keep going with our scale of that base of the exponential function, and we'll see how slowly a biting disease would actually spread. So let's go back to the whiteboard. So after airborne, smaller than that would be a base which has to do with material. Okay, so spreading through material, an infected person touches something, you touch something, you can get the infection. So this is something like stomach flu, for example. It can spread through material that an infected person has made contact with, compared to something like, a cold or the standard kind of flu that has nose and throat symptoms, which is airborne, right? During flu season, pretty much everybody is going to get an airborne flu or cold or something like that. Whereas when stomach flu is going around, well, it's not as guaranteed that everybody's going to get it. There's going to be a whole lot of people who don't get it, right? So the B value for a virus that spreads through material is smaller. Even smaller than that is the B value for a virus that spreads through direct contact with a person. Okay, so it's not enough to touch something they've touched. You got to touch the actual person for the virus to have a decent chance of spreading. So this is something like skin. Some skin infections, for example, might spread this way. An even smaller B value than that is something that spreads through bodily fluids. Okay, so it's not enough to make contact with a person. You actually have to be exchanging bodily fluids for the disease to have a decent chance of spreading. And an even smaller B than that is something that spreads through sexual contact. Okay, so this is not just exchange of bodily fluids. It's not just contact with another person. It is a very specific kind of contact and exchange of bodily fluids, which is much less likely to occur than just making contact with a person or just any exchange of bodily fluids. Okay, so what is going to spread the fastest? Airborne infections. Okay, that's why during flu season, pretty much everybody gets something like that. Now, what about a disease that would spread through biting? Well, that's going to be somewhere in there. Okay, that is going to be our B for biting. Okay, a disease that spreads through biting. Why? Well, it is an exchange of bodily fluids, but it's also a very specific one, not as intimate as sexual contact, but it is, not just any exchange of bodily fluids, but something that is quite specific. Okay, so it's going to be somewhere in there. So it's way down here on the scale, very far away from your airborne infections that would actually turn into these kind of global pandemics very quickly. All right. And this isn't just theoretical. We know this because humans have been dealing with an infection that spreads through biting for a long time, and that is rabies. Okay, there have been rabies outbreaks historically that humans have had to struggle with, but it's never turned into a kind of global pandemic like airborne infections have turned into. Now, we also have fictional stories about biting diseases that have to do with werewolves and vampires, okay? And those stories are actually more realistic in terms of the spread of the disease because you don't have this global pandemic of lycanthropy. Okay? No, you just have this small number of werewolves or vampires or maybe even just one, and people know about them and they try to avoid them and protect themselves from them. But overwhelmingly, the global population of humans is fine, right? There's just this small number of infected that people are trying to contain. Now, interesting when it comes to zombie movies, and The Last of Us pretty much is a zombie story, right? Certainly in the show where it is a biting disease. That's a different kind of myth than the vampire stories or the werewolf stories. When you have zombies, it's not just a small contained group, okay, that function as individuals. No, they function as a horde and attack people in very large numbers, and the army gets involved. So the zombie stories, that theme probably has more to do with the spread of some sort of ideology brainwashing people, and it turns into a large-scale military confrontation, and including in The Last of Us, right? The military gets involved. In a lot of zombie stories, the military gets involved. So the theme isn't even a physical infectious disease, right? If we're trying to understand the zombie stories, right? It might just be something more political, for example, right? So from that perspective, it doesn't really matter if we have the disease spread through biting or through being airborne, because we're not trying to depict how accurately an actual virus would spread. You're just using the spread of a disease to symbolize something else that causes a breakdown of society and these large-scale conflicts to occur, right? It doesn't have to be realistic, right? Like every other zombie movie where it's spread through biting and people face off against these zombies on a military scale, it's not trying to be realistic, right? The disease is not airborne, but it is still kind of cool that it was airborne in the video game that the story was based on, which does make the spread somewhat realistic, right? In the show, they came up with an idea to try to explain how it could spread quickly through food supply, maybe because they understood that, well, something that's not airborne actually would not spread so fast. So, thought you might find that interesting. I hope you enjoyed that, and until next time.